Hey everyone, here's a video for my Algebra 1A live class for week 2 over expressions. So week 2 expressions, we're dealing a lot with letters, numbers, variables, and putting them all together in addition, subtraction, multiplication, and division. For week 2, make sure you're looking at an online CK12 textbook, taking notes, doing practice problems as you go through this video. Use this video and our textbook to help you do the weekly assignments. Let me know if you have any questions. Come to my online classroom, send me a text, message, anything you need to do. I want to make sure you're keeping up and doing well in this class. All right, the objectives for week 2. Here's what we're going to learn this week. I want you to be able to use variables to write algebraic expressions and equations. I want you to learn how to evaluate algebraic expressions, what that word evaluate means. We're going to use exponents in evaluating algebraic expressions. I'm going to practice using the correct order of operations when evaluating expressions. And we're going to simplify expressions using the distributive property. Okay, so what is algebra? Algebra is the process of doing math, but we now have variables to represent unknown numbers when adding, subtracting, multiplying, and dividing. So we've been doing all that stuff, adding, subtracting, multiplying, dividing, up to this point with fractions, decimals, negative numbers, positive numbers. But now we start introducing variables into things, and that's what makes it algebra. A variable is a symbol, typically it's a letter, oftentimes x, that represents an unknown number. So here we go, the following is an algebraic expression. Here I've got 5x minus 9. What does this mean? Well, if I translate this out, when we have two things right next to each other, that indicates multiplication. So I have a number, an unknown number, that's my x, multiplied by 5, then subtract 9. So we take away 9 from whatever 5 times our x is. So it's like directions, right? It's telling me if I did know what x was, here's what we do to it. We multiply it by 5 first and then subtract 9. And that's the mathematical operations that we're doing to our variable. Okay, let's take that expression and let's evaluate it. When we talk about evaluating an expression, evaluate means calculate it out and find out what it equals. So we're going to evaluate or calculate the expression if we make x equal to -2. All right, let's take that -2 and replace x with -2. So now this expression becomes 5 times -2 minus 5. When we have letters and numbers or two numbers right next to each other, that indicates multiplication. Sometimes students get confused on that, but that is 5 times x. We don't put the multiplication symbol. We can, but we don't have to. All right, let's evaluate this out. So I multiply first. 5 times -2 is -10. So now I've got -10 minus 9. And then I can do the subtraction. -10 minus 9 is going to be -19. There's my solution. I just evaluated the expression for when x is -2. Now let's do the same thing again, but this time let's do it for a different number. Let's do it for x equals 4/5. Same thing, same expression. So 5 times 4/5. I'm going to replace x with 4/5 minus 9. Okay, what does that equal? 5 times 4/5, so I can think of that as 5/1 times 4/5 minus 9. Multiplying fractions, I can multiply the numerators and denominators. So 5 times 4 is 20. Over 1 times 5 is 5 minus 9. 20 over 5 simplifies down to 4. And 4 minus 9 is equal to -5. So there's the solution. If I substitute 4/5 in for x into this expression and evaluate it, I get it that it's equal to -5. There's a couple examples of evaluating expressions for you. All right, let's use some variables. Let's go through some situations and practice translating words into an expression or into an equation. Oftentimes, this is the most difficult part of an algebra class is It's sort of like a language thing. I have to take all these words in this context and this problem and figure out how to write it in the language of algebra using symbols and numbers and operations. And that can be kind of tricky at first. All right, here we go. If we get paid $10.50 an hour, so every hour, $10.50, and I work an H number of hours, write an equation. This is different than an expression. An equation has an equal sign that represents the hours we need to work to make $100. Okay. So $10.50 per hour. One thing that helps with writing an equation is to think about what's going on. So if I work hours, let's make a little chart. If I work 1 hour, we make $10.50. If I work 2 hours, I make 2 times $10.50, so that's $21. If I work 3 hours, that's 3 times $10.50, or $31.50. And we can quickly see that depending on however many hours I work, H number of hours, I take $10.50 and we multiply it by H. So that's going to help me put together the equation now. If this is how much money I make, I want to know, when do I make $100? So $10.50 an hour for number of hours H, there's my variable. When do I have $100? There's an equation, there's an equal sign that represents this problem now. Let's translate another one. The length of a swimming pool is 8 less than twice the width. Write an expression for the perimeter, write an expression for the area. So the perimeter, if I think about a swimming pool, the perimeter is the length plus the length plus the width plus the width. I add all 4 sides together, right? And for the area is length times width. Now let's draw a picture of my swimming pool over here. So we have a rectangular swimming pool. There's the length, there's the length, there's the width, there's the width. But now I'm given some information about my length and my width, right? I'm told the length of a swimming pool is, so the length L, let's translate it in the right symbols, is, that's an equal sign, 8 less, that's minus 8, then twice the width. So there's my width, and twice the width would be 2 times the width. Now if I put all that together in an equation now, the length is twice the width, but it's 8 less than that, so minus 8. And there we go. Now we have an expression that is equal to the length. And so I can replace the length with 2w minus 8. It's the same thing, twice the width minus 8. And you say, well, why are we doing this? Well, I'm helping you guys give an example through thinking about a problem, rewriting it, using variables, using expressions, putting it all together, because this is stuff we're going to be doing a lot of this year. Algebra is a problem-solving tool. We solve things we don't know by writing it out in math, solving it out, and then going back and answering whatever question we're trying to do. And we're going to be doing problems with perimeters, areas, rectangles, and so starting to think about these types of word problems are really going to be helpful in the future. Okay, let's write an expression now. So instead of length plus width, let's use 2w minus 8 in place of the length. 2w plus 8 minus 8, that's one length, plus 2w minus 8, another length, plus w plus w. There's an expression for the perimeter of the pool. And I can even say, well, there's 2 of those, so how about 2 times 2w minus 8 plus 2 times w. I could switch it that way as well too. Now let's write an expression for the area. Area is length times width. Well, let's use our 2w minus 8 for the length times the width. That would be an expression now for the area. Hopefully you're kind of catching on about how we can use all these variables, symbols, operations to translate things around us into some algebra. Let's get a more complicated one. What if I want to work with expressions that have multiple variables and exponents? All right, how do I take all this and evaluate it if x equals 4 and y equals 1. All right, same idea. We're going to substitute things in. So we've got 3 times 4 plus y is negative 1. And on the bottom of the fraction, I got y squared, so negative 1 squared plus 6. All right, let's evaluate that. With a fraction, I need to treat each part separately. So I need to simplify the numerator, then simplify the denominator, and then see if I can divide. So on the top, 3 times 4, that's going to be 12, plus negative 1. On the bottom, I have negative 1 squared. That's negative 1 times negative 1. Well, negative times a negative is going to be positive 1 plus 6. And, well, that just equals 12 plus negative 1 is 11. 1 plus 6 is 7. It's an improper fraction, so 7 goes in 11 one time with the remainder of 4. So there we go. We just evaluated this expression for when x equals 4 and y equals negative 1. So as we get into more complicated problems, we need to have a clear idea in which order we do all our math operations. Fortunately, we've got PEMDAS, right? Let's review what PEMDAS means. If I'm evaluating this expression, the first thing I need to do is look for parentheses. Simplify everything in parentheses first. The parentheses are telling me focus on this part and then look outside of it. Parentheses, there we go. After that, I want to look for exponents, powers. Those are a shorthand way for multiplication. We'll deal more with those, but I want to deal with exponents. Then I look at multiplication from left to right and division from left to right. I can do those at the same time because multiplication and division are really related. And then finally, I go back and I do all the addition and subtraction from left to right. That's the standard worldwide order in which to work through math problems. So let's go ahead and do this one right here. First thing I want to do is deal with any parentheses. I don't see any parentheses. There's one here, but I've already simplified everything. It's just negative 2. So parentheses are done. Let's go look through an exponents. I got a 7 squared. Before I can do anything with that 7, I need to square it. So that's 49. So now we've got 17 plus 3 minus 4 times and negative 2 divided by 49. Exponents are all done. Let's do multiplication and division from left to right. 17 plus minus times. Next up is going to do 4 times negative 2. So now we've got 17 plus 3 minus negative 8 divided by 49. And I have one more division. Now let's do negative 8 divided by 49. So we've got 17 plus 3. I'm just going to leave it as a fraction. Minus negative 8 49ths. Now the last part is addition and subtraction. Left to right, 17 plus 3 is 20. Minus negative, that fraction, 2 negatives actually change it into plus 8 49ths. And I can put it finally together like this, 20 and 8 49ths. As you're going through this class, leave your answers in fraction form whenever possible, unless you can express it as an exact decimal. If I do 8 over 49, that's this crazy irrational number, and I have to round it at some point. So leaving it as 20 and 8 49ths is a much better answer than like 20.2135 or whatever we get when we calculate it out. So leave your answers as fractions unless it's an exact decimal. There we go. That's order of operations running through that quick thing. If we follow this, that way we'll get the same answer every single time because we're doing it in the correct order. All right, last topic for the day, distributive property. As we start to simplify, work with expressions, parentheses, all these different things, it's nice to be able to simplify things down or rewrite it. You're going to work on a lot of the distributive property in your Desmos activity for this week. Here we go, distributive property. This just says we can take something in front of the parentheses, like this value a, and it's multiplying what's in the parentheses, but I can rewrite it to multiply each thing individually in the parentheses. So a times b and a times c. It helps us rewrite expressions either distributing or reverse distributing so that they're easier to work with. We want to be able to rewrite expressions. All right, here we go. First example. This is -3. It's multiplied by 5 minus a. How do we distribute that? So I'm going to take -3. First of all, it has to multiply the 5. So we got -3 times 5. Then we have the minus sign. Then it's -3 times a. So we've got -3a. -3 times 5 is -15 minus -3a. And we have two negative signs. Subtracting a negative, I can change that to -15 plus 3a. And if I wanted to, I could even write the variable term first and change it to 3a minus 15. These are the same thing. When you're adding, it doesn't matter which order you do it in. So as long as you keep this negative with the 15 and the 3a is positive, you're good to go. So there you go. There's using the distributive property to simplify the expression. I'm asked to evaluate, so let's just do another quick example of evaluating. If a is 14, let's go and put 14a in for a. 3 times 14 minus 15. And what do we get? 3 times 14 is 42. 42 minus 15 is going to give me 27. All right, so what did we cover? We covered using variables. We covered using expressions. We covered writing equations. We evaluated all sorts of expressions. We used exponents. We practiced the order of operations, and we reviewed and learned about the distributive property. These are all things I'm going to want you to practice on and work on for this week, both in your assignments. If you need tutoring, I want you to get really solid in those ideas. Hope this video is helpful, and I look forward to working with you guys the rest of the week.